Okay, hi there. Today, for pre-calculus, I'm going to be looking at sigma and arithmetic sequences. So this big symbol right here is called sigma, the thing that looks like the big, I don't know how to describe that, kind of E-looking shape. So that's a sigma sign, and you see this in math a lot. It looks complicated, but what it really means is just it's addition. It's the abbreviation for addition, which means sum. So sum is what you get when you add up all the stuff. So that's really all that big fancy symbol means, and you see it on fraternities and sororities as well, you know. So it's a Greek letter, and yeah, so when we use it in math. Anyway, so if I was using this symbol and I wanted to, come up with what's um, the symbol for all these things added up here. So I'm going to use this. It's called the summation sign also. You might hear that. If you hear me referring to that, so I'm talking about the sigma sign. So the way this works is, if I plug in down here, it says what n starts with, which would be, in this case, 1. So you can see that the denominator, if I make that n, it starts with 1, and then it goes to 2, and then it goes to 3. That's going to be n, which means my formula would be 6 over 1 plus n, okay? And if by using that, I can actually put that right here, because this is where the explicit formula goes in that summation thing, okay? Explicit formula. Now the other part I need is there's two numbers. There's one at the bottom of the sigma sign and one at the top, and that tells you what n goes from. It goes from 1 to 5. There would be 5 numbers in the sequence then, and you'd add them all up, okay? So in this case, if I plug in, let's see, this would be 1, 2, 3, 4, gives me 5 in the denominator, which means n up here has to go up to 104, okay? So I'm going to put that in the numerator, 104, and now this is what I'm looking for, which means these two things are the same thing, all right? So, you could get it, this is the whole sequence up here, 6 over 1 plus 1, 6 over 1 plus 2. These are the same things as what I just wrote with that sigma sign, okay? And I know that this takes a few minutes for you to wrap your head around, but please start now. So here's number 2, a little trickier. So I have to find out what's my formula going on here. So just like in the last video, suppose I took that 2, -4, plus 8, minus 16. I got that alternating positive negative thing going on again. So if I take -1 and I take it to the nth power, I would get negative, positive, negative. I want it to start with positive, so if I add 1 there, now I've got positive first, negative second, positive third, etc., etc. Now I need to find out what's going on with that pattern there, 2, 4, 8, 16. Well, those are the powers of 2, and if I put it to the nth power, I'll get, and plug in 1 for n, I get 2 first, and then 4, and then 8. So that's the explicit formula. So that goes after the sigma sign. Now once again, at the bottom of the sigma sign is the first number that you're plugging in. Usually it's 1. Not always, but usually. Sometimes they'll tell you to start with 0 or 5 or whatever. But that's what this number here represents, is what the first number you're plugging into the sequence is. Okay? Now the last thing is what's the last number in the sequence. So I need to figure out what 2 to the what power equals 128, okay? Which should be 6 in this case. So I got 6. Double check my notes. Oh, is it 7? 2 to the what power? 2 to the 7th power is 128, so it should be 7, not 6. 6 gave me 64. So it goes from 1 to 7. So there's 7 numbers in the sequence, and if you added them all up, what do you get? That would be the other thing you could do is what does it turn out to be? So anyway, those questions will come up a little bit later. Here's number 3. Let me see if I can put this one into a sigma sign. And if I take this my explicit formula, I got 1 in the numerator, okay? 1, 2, 3, 4, 1 times 4. So these numbers are just n, right? Because it's just going up by 1. And then how do I get 4, 5, 6? Well, those are also going up by 1. However, I need the first number to be 4. So if I add 3 to it, and then I get 4, 5, 6, there we go. That works. Okay, there's my formula. And how far does that go? It just says it goes up to 15. So that actually, this one will tell me what n is. So 12 is going to be the last number I plug in. And once again, I start with 1. So it goes from 1 to 12. And there's my my sigma sign for it, my summation equation, okay? So those things are the same thing, just written differently. Next one. Numerator. Let's start with the numerator. This one's actually the tricky part. You got to kind of see this one. 3, 7, 15. You know, if you were to add 4, and then I add 8, and then I add 16. So those are powers of 2 up there, okay? Which means if I take 2 to the nth power, that'll give me that pattern. But I get, unfortunately, if I plug in 1, 2, 4, or 1, 2, 3 for n, I get 1, 2, 8, which gives me, I'm one number short over there. So, oops, this should have been 1, 2. The second is 4, not 2, Mr. Flory. So what I want to do is actually subtract 1 from that. And now if I plug it in, I get 2 to the second power is 4, 4 minus 1 is 3, 2 to the third power is 8, 8 minus 1 is 7, 2 to the third power is 16, 16 minus 1 is 15. So there's my numerator. Denominator, what's going on with my denominator? I got 1, 2, 6, 24. Remember back from that first video, that's actually the factorial sequence. Okay, so if I put n exclamation point, this would be, 1 factorial, 2 factorial, 3 factorial is 3 times 2 times 1. All right, remember that stuff? That gives me 6. So there's my denominator. So where did I go from? N started with 1, and it went up to 6 factorial gives you 720. So it goes from 1 to 6. Okay, so there's that one. Now they say evaluate. We're going the other direction. I gave you the sigma sign, and you're going to evaluate it. So what you want to do is, especially when there's only 5 numbers, because you can see here that it goes from 1 to 5. I just plug them in, and then I'll add them up. All right, that's what I'm going to do. It's not the only way to do it. There is equations we'll get to later on, but right now that's what I'm looking to do. So if I plug in 1, I get 2 times 1 plus 3, which is 5. I equals 2. That would be 2 times 2 plus 3, which is 4 plus 3 is 7. If I is 3, I get 2 times 3 plus 3, which is 9. If I is 4, I get 11. If I is 5, I get 13. So if I add up all these numbers here, these 5, I'll end up getting my answer, which is 45. Okay, and that is what the sum of all those numbers is. 45, and that's what I'm looking for. Okay, I'm looking for the answer. All right, next one. 6 numbers to plug in. Oh, 7 actually, because k starts with 0. So if I took -1 to the 0 power over 0 plus 2, this would give me anything to the 0 power is 1. Gives me 1/2. There's my first number. And if I plug in my second number, I get -1. Move this slightly. -1 to the first over 1 plus 2 gives me 1/3. The next one will give me negative. I made a slight mistake. That should have been negative 1/3 because the numerator will be negative. So the numerator is just 1 over and over again, and then you keep adding to the denominators. What's going on with this pattern? 0 plus 2, 0 plus 3, or 2 plus 3, 2 plus 1. I put that in the wrong spot. So this goes positive, negative, positive, negative. Numerator stays at 1. Denominator goes up by 1, which will give me 4, 5, 6. The question is, where does it stop? If I go up to 6, plug in 6 to the denominator, I get up to 8. So it's like this, and remember it goes positive, negative, and then you're going to add all those up. Now there's two ways you could do it. You could do it with fractions, which if you do it out, you get 307 over 840, or probably the easier way is decimals, which is 0.365. Okay, and there's your answer. 7. This one, negative 3 to the j, starting with 1. So if I go negative 3 to the first power, that's negative 3. Negative 3 squared will give me positive 9. Negative 3 to the third power, just plugging in 1, 2, 3, 4 for j, because j goes between 1 and 4. This will give me negative 27, and next will be positive 81. Whoa, shoot. Everybody wants to be in show business, including my cat Pepper. All right, so going back to this. So I got, let's see, did I get all 4 numbers? I got all 4 numbers. Awesome. So I plugged in 1, 2, 3, 4, and if you add them all up, I should make those plus signs in between. Throw out summation, not commas. I just keep wanting to do that. And if I add up all of those numbers together, I get 60. Okay, so that's the answer, 60. Next one, number 8. If I plug in 1 to 9 in this for n, all right, starts at 1, which gives me 1 over 1, and then 1 over 2, 1 over 3. Instead of putting the commas, Mr. Flory, you should be putting the plus signs. This goes all the way up to 9, 1/9. And after that, I'd probably be taking my handy dandy calculator and adding them all up and getting 2.82. You can check my math and get back to me if I made any mistakes, but that's all you do with number 8. All right, next we got the arithmetic sequences. Find the explicit formula. So in the last video I gave you this equation, a of n equals a of 1 plus n minus 1 times d, and broke it down for you. If you've forgotten it, you should go back in your notes or watch the video again. So I got a of 1 is the first number in the sequence, which is 6. D is the common difference, which is what you get when you subtract the first number from the second number, which is 11. And n is whatever the number is. That's usually in there like an x in a graphing y equals 2x plus 3. So I got a of n equals 6 plus n minus 1 times d. And then you simplify it, all right? Don't just leave it like that. So I'm going to do that over here. If I took 6 plus 11n minus 11, which is what I get when I do distributive property, and then simplify, I get 11n minus 5, and that is the answer I'm looking for. And then you can find anything you need. If I want to know what the 100th term is, I plug in 100 for n and go 1100 minus 5, which will give me the 100th number. Okay? All right, you try. Once you see if you can come up with the arithmetic explicit formula, okay? Using that same equation. So if you don't want to see the answer, hit pause. There's the answer. Moving on. So this one a little trickier. This time they don't give you the sequence. So I'm going to take the a of n equals a of 1 plus n minus 1 times d, and I'm going to plug it in. They did, however, give me a of 1, which is 4, and they gave me d, which is negative 5/2. I'm going to put parentheses around that so that it doesn't look like subtraction. So I get this. All right, now I'm going to do the same thing. I got enough information to find the answer. I should do distributive property there. So I get 4 plus negative 5/2 n plus 5/2, okay? And then if I take that and combine 4 and 2.5, I get the answer. A of n equals negative 5/2 n plus sorry, I drew a blank there. 8 over 2 is the same as 4, so 8/2 plus 5/2 is 13/2, and that's what goes here. Or you could use decimals if you like, but I figured the 5/2 is in fraction form. Why not the other one? All right, and then I got this one over here. Where they give me the third and the fifth number in the sequence. There's a couple ways you could go about doing this. I need to know the first number in the sequence. I need that, and I need the common difference. So if you take this equation, and I go a of n equals, so the third number they say is 65. So if I go, so because these numbers are 2 apart, this is the third number in the sequence and this is the fifth, I want the one in between that. I'd like to know what the common difference is. So if I subtract those numbers and then divide by 2, I get the common difference, okay? Which means when I do that, 93 minus 65 is 28, and 28 divided by 2 is 14. So that's my common difference. And then I'm going to look to make sure, are they going up or down? Well, 93 is bigger than 65, so they're going up. So 14 will be positive, not negative. Which means if I take 65 and I add 14, this would give me a of 4, which in this case is 79, okay? The other thing I need is the first number in the sequence. So this is actually a pretty easy thing. Now that I know the common difference, I can figure it out. A of n equals a of 1 plus n minus 1 times d, and d is 14. So the other thing I know is that the third number in the sequence is 65, which means a of n will be 65 when n is 3, which means I go 3 minus 1. And now you can find out what a of 1 is by solving that, okay? So it's nice when they give you one of those numbers, you can figure out the equation. 3 minus 1 is 2. 2 times 14 is 28. And now I can solve that, subtract 28 from 65 is 37. So that's my first number in the sequence. So my equation, a of n, equals the first number in the sequence, which is 37, plus, it's not plus or minus, plus n minus 1 times d, which is 14. And if you like putting that 14 in the front, you can do that too. Oops. These are both the same thing, just written differently, okay? All right. That was my last problem, so I'm going to call it. All right. Have a great night, and I will see you all soon.